So, morning all of you. Please mute your mics. I hear some background noise. Please mute them. Okay. So in the last class, we saw how to obtain the object reference of a thread and how to create a thread in two different ways by extending thread class and by implementing runnable interface. Right? Yes. So today we'll talk about thread lifecycle. Okay. Yes. Just a minute. So thread lifecycle phases. So a thread basically it will go through various phases in its life cycle or life cycle states, I can say. A thread it goes through various states. So what are those states? Let me just name name them. New, runnable, say running, sleep, wait, or blocked state, and dead state, I can say. Yes. So a thread in its life cycle, it will go through various phases like this. Running state, runnable state, running state, sleep, wait, blocked state, or dead state. So let me demonstrate the states here. So the first state is the new state. Initially when we create a thread class object, when we create the thread object, when we create a thread object, I can say that the thread is in new state. So when the thread is in new state, I can say that it is just a normal thread, a normal object, nothing more than that. So there is nothing special about this thread when it is in new state, I can say. Okay, there is nothing special about this thread. Just a second. Yeah, sorry. So there is nothing new about this. There is nothing special about this thread. Okay, when it is in new state. So it is just like any other object, thread object, that's it. And it is not, it is just like any other Java object. And I can say that, this thread is not yet ready for execution. It is not yet ready for execution, and the thread is in new state. So here you see we have created the thread object, right? I can say that the state of the thread is new. Even after naming the thread also, still it is a new state itself. Yes. Now you see here we'll call the start method on the thread, right? We'll call the start method on the thread. Yes, start method on the thread. So when you call the start method on the thread, yes, the sorry, when we call the start method on the thread, this thread will move from new state to runnable state. When we call the start method on the thread will move from new state to runnable state. So what is special about the state? What if the thread is in runnable state? When I say the thread is in runnable state, that means the thread is ready for execution. Okay, the thread is ready for execution. Thread is ready for execution, I can say. I'm sorry. So but it is not yet started with the execution. Okay, it is not yet started with the execution. But actually I told you people that when we call the start method, just a second. Yeah, I'm sorry. So when we call the start method, generally I told you people that the thread will start with the execution, right? It will start executing. But now I'm saying that it is not yet started with the execution. It is just you know ready for the execution. It is not yet started with the execution. It is just ready for the execution, I can say. So it is ready for the execution here. Okay. Yes. But why the thread is why the thread did not start with the execution here? Why it is only ready for the execution? Why it is not yet started with the execution? What do people think? Why it is not yet started with the execution? What do people think? When we call the start method, I told you people earlier that it will execute, right? But now I'm saying that it is not. It won't start execution immediately, but you see, it will move from new state to runnable state. Why so? Because you see, when we call the start method, when we call the start method, you see the thread, in order to start with the execution, the thread, in order to start with the execution, it needs processor. It needs processor. Okay, but the processor, it might have been assigned to some other thread here. The processor might have been assigned to some other thread. Yes. So this thread will be waiting for the processor. Okay. That's the reason why this thread is waiting for that processor, I can say. This thread is waiting for the processor to be allocated to this thread so that it can start with the execution. So when I say the thread is in runnable state, when I say the thread is in runnable state, that means the thread is ready for the execution, but all it needs is the processor. It's waiting for the processor, I can say. Once the processor is assigned to the thread, so it will start with the execution. That means it will move from runnable state to running state. It will move from runnable state to running state here. Yes, that is what happens. Okay. Yeah. So when the thread is in running state, that means I can say that this thread is actually executing the task which is assigned to it. That means, so it will be executing which method? Where is the task defined for the thread? So when I say the thread is running, so that means which method it will be executing generally. Yes. Yes, the run method. Yes. When we say the thread is running, or that means, here it is executing the task which is assigned to it. And generally the task for the thread, that we define the task in the run method. Okay. Yes. Fine. So once the thread finishes execution, you see that means generally the thread will be executing the run method. And what if once the thread finishes execution of this run method? What if the thread is done executing the run method? Then what happens to that thread? What do people think? What if the thread is done with the execution of that run method? If it is done with the execution of the run method, that means, the thread has accomplished its task. Okay, the thread has accomplished its task. So now the thread from the running state, it will move to the dead state, I can say. It will move to the dead state from the running state. Yes, it will move from running state to the dead state. Yeah. So now for suppose let's consider a case here. When the thread is executing, that means when the thread is in running state. When I say the thread is executing, that means when the thread is in running state. Let's say, what if the thread is instructed to sleep? What if the thread is instructed to sleep? Yes. So if the thread is instructed to sleep, then you see the thread will move from a running state to the sleep state here. The thread will move from running state to the sleep state. Yes. Okay. So it will move from the running state to the sleep state. Yes. Okay. Now, if the thread is in sleep state, what does that means? When the thread is in sleep state, that means the thread is actually not executing any instructions. You see, the thread, it is not executing any instructions. It is just waiting. It is sitting idle, okay, for a period of time. Once that time period expires, so you'll find that the thread will come out of the sleep state. Now, after the thread comes out of the sleep state, okay, after the thread comes out of the sleep state, now will it move to the running state or runnable state? That is a question which I got for you people. So what do you people think? The thread, after it comes out of the sleep state, will it move to the running state or runnable state? Okay, but you will find that most probably it will go to runnable state itself, because you see, when the thread is in sleep state, the processor might have been assigned to some other thread, right? The processor, it might have been assigned to some other thread. Now you see this thread, again, once it comes out of the sleep state, it has to execute, but in order to execute it needs processor. So you see that processor might have been assigned to some other thread, so this thread will be waiting for that particular processor. So that means if the thread is waiting for the processor, that means the thread is in runnable state. So from the sleep state, the thread will come to this runnable state here. Okay, so hope you people got it. Yes. Okay. So any questions in this regard, please let me know. Okay, fine. So we got wait of block state also, but we'll see that later. Okay. So when I talk about that thread communication, we'll see that. Yes. Okay. Yes. So let's move on. Now we'll talk about thread synchronization. So which you people are waiting. So this is very important. But before we start with this thread synchronization, so I have to prepare you people for the background, I can say. Yes. With some background work. So let's try to do that. So for suppose let me copy this savings account class. Okay, I'll remove this exceptions list and all. And so I want this withdraw method and remove the other withdraw method. So we'll consider one thread for this synchronization. Okay, let's consider this method withdraw. Okay, now this is savings account class. Now I want to do one thing here. What is it? I would like to create a thread, and to that thread I want to assign the task of reading that savings account details. Okay, what I want to do, I want to create a thread, and to that thread I'd like to assign a task. What is the task? The thread is supposed to read savings account details, savings account object details. So that is what we are supposed to do. So let's see how to start. Okay, so first of all, we'll define a class. Okay, first of all, let's define a class. I'll call it as account service. You can give any name you wish. And I'll make this class implements runnable interface, and we'll override this run method. Now we have to define the task for the thread. So what is the task for the thread? As I told you people, I want this thread to read the account object details. Okay. So if this thread has to read the account object details, then this thread should have access to that account object, right? See, I'll do this. So what I'll do, I'll declare a reference variable here of type savings account, and I'll add a parameterized constructor here. So through that constructor, we'll supply that savings account object reference. Okay. So now in the run method, I'll write the code to read that account details. Say account number, savings account dot, sorry, get account number, and similarly we'll read the balance, savings account dot get balance. Yes. Okay. So this is the task which we are assigning to the thread. So what it is supposed to do, it is supposed to read that account details. So we are making sure that the thread has got access to that savings account object. For that, you see, we have declared a reference variable, and through the constructor, we'll supply that savings account object reference here. Sorry. Through the constructor, we'll supply that savings account object reference. Yes. Okay. So first, I'll create a savings account object, you see. Let's say we'll create a savings account object this way. And after creating the savings account object, we will create that account service object here. So which implements runnable interface. It takes that savings account object reference, right? You see to that account service class constructor, we are passing that account object reference here. So that account object reference, it is passed onto the constructor. So constructor will take that account object reference. In turn, it will store it into this variable. Now you see this statement. Okay. So now we have supplied that object reference, account object reference. Now let's create a thread object here and pass that account service object reference, okay, which implements that runnable interface. Now in that account service class itself, we got that task defined for the thread, right? I'll start the thread. I'll name set name it. I'll name that thread. Let's say some account transaction one or something like this. Just and then we'll start the thread. Yes. Okay. We'll start the thread here. So let's run this code. You see the thread. So it executes and it is able to read that account details. So that is the task basically which we have assigned to that thread. Okay. So now what we did so far, is it clear for you people? What we did so far, is it clear for you people? Any questions in this regard? Okay, fine. Now here, what I want to do is, all of you, this is very important. I want to create another thread. I want to create another thread, and to that thread also, I want to assign the same task. I want to assign the same task. That means that thread also should be able to access that account object and read the account object details. That thread also should be able to access the same account object. Sorry. So what do you people think? What to do? So hope you understood the question, right, all of you? So I want to create another thread, and to that thread also I would like to assign the same task. That thread also should access the same account object and read that account object details. Okay. So what am I supposed to do here? Okay. You know, here already we got an account service class object in which we have the run method defined. In that run method already we have defined the task. You see, to this account service object already that account object reference is passed, right? So what I will do is here simply I'll create another thread here this way. Okay, and to that thread we'll pass that account service object reference. Okay, and then we'll start the thread. Yes, set name. So we'll name the thread. So this is account transaction 2. You see, to this thread class constructor also we are passing the same uh, is account service object reference in which the task is defined, right? Yes. Now let's start the thread 2. Okay, so two threads will be created, and both the threads will operate on the same account object. You see, so hope you people got it. So now both the threads have access to the same account object and they are reading the same account object details. Yes. So is this point clear for you people? Okay. Now let's move on. Here these two threads are operating on the same account object. That is a very important point that you need to realize. And when two threads are operating on the same object, there can be some issues. Can you people tell me what could be the issues if both the threads are operating on the same account object? Yes. What will be the issues if both the threads are operating on the same account object? What could be the issues? Yes, that's right. You know, there is a possibility that these two threads may overlap with each other. The threads may overlap, overwrite the data. Yes. So that is the issue. Yeah. So I'm going to demonstrate that issue now. Okay. Let me demonstrate that issue. For that, I have to make some changes to the savings account class withdraw method. So I'm going to use this withdraw method. Let's say what I will do is I'll make the threads to execute this withdraw method. Okay, next thing what we'll do is we'll make the threads to execute the withdraw method. Okay, yeah. So when the threads execute this withdraw method, let's see what happens. Now I will try to print the details also. Okay, let's say thread dot current thread dot get name. Sorry, this thread, whichever thread first you see, whichever thread executes this method, first of all, it will check for the balance, right? Whichever thread executes this method, it will check for the balance first of all. Now I will print the details about the thread which is executing this method. Okay, we'll print the name of that thread. This way. Is about to withdraw the amount, or is going to withdraw the amount. So first it will check for the balance. If it finds sufficient balance, then it will print that message that it is going to withdraw the amount. Okay, it will print this message that it is going to withdraw the amount here. Yes. Okay. Now after printing this message, thread, let's say it won't immediately withdraw the amount. Let's say instead it will go into the sleep mode. Thread dot sleep. Let's say for 500 milliseconds. Okay. Just a minute, please. Just a minute. Yeah, I'm sorry. So you see, after the thread, after it checks for that balance, it will print this message, and it won't immediately withdraw the amount. Let's say it will go into sleep mode, and after it comes out of the sleep mode, it will withdraw. And after it is done with the withdrawal, let's say it will print a message. Let me copy this. Thread is done with the withdrawal. Yes. Okay. Yeah. Now, why we are adding a sleep method here? We'll see that later. Don't worry. But just assume that we have the sleep method definitely. So, what if the thread? You see, if this condition fails, that means thread will not be able to withdraw the amount, right? Yes. In that case, we'll print error. We'll print a message as well here. There is not enough balance for the thread. I'll print the thread details. Get name to withdraw. Yes. There is not enough balance for the thread to withdraw. We'll print that message. Yeah. Okay. If that condition fails, this is the message which we'll try to print. Okay. Yes. Fine. So that means I'm trying to just make sure that I print all the details about the thread activity. Okay, which thread is going to execute this method and all such details. So we are trying to print that details here completely in detail. Yes. Okay. Now I'll change the task for the thread. What is the task for the thread? This time our thread task is going to change. So it will execute this for loop. In the for loop, I will add this code. So what does this means? Can you people explain me? So what the thread is supposed to do now, what it will be doing? So this thread will be executing the withdraw method 5 times. Each time it will be deducting 1000 rupees. So you see, we'll only start one thread. I'm only starting one thread. Okay. Now here, will there be any issue of overdrawing this account? I can say no. there won't be an issue of overdrawing the account. Okay, yes, the account will not be overdrawn. If you want, we'll check this. After each withdrawal, we'll check the balance. If it is less than 0, then I can say the account is overdrawn. We'll print error message. Account is overdrawn. Yes, that's it. Let's run this code. You see, the thread, it executed 5 times without any issues. Okay. Now, so far what we did, hope this is clear for you people, right? You see, the thread executed normally without any issues. Hope this is clear for you people. We are just printing the details. See, 1, 2, 3, 4, and 5 times the thread has executed that withdraw method. In the withdraw method, these are the instructions which you got. Yes, that's it. Okay. Yeah. Now let's introduce another thread. See, the second thread here, and to this thread also we are trying to assign the same task. So it has to execute the withdraw method 5 times. Each time it is supposed to withdraw 1000. But you know what is the balance in that account? What is the initial balance of that account? Have you noticed it? What is the initial balance of that account? It is 5000, right? That means these two threads altogether in combine, they cannot withdraw more than 5000. They cannot withdraw more than 5000. Yes. Right? Now you see, every time the thread is about to withdraw that amount from the account, first of all it will check for that balance. Okay, so there is no scope of overdrawing the account, right? Yes, the account should not be overdrawn. Now let's run this code. Okay, but you see, at the end you will find that this account is overdrawn. How come it is possible? You will find that this account is overdrawn. Yes. Okay. This is an issue, right? The account was not supposed to be overdrawn. How the account was overdrawn? Can someone explain me? Yes. So why the account was overdrawn? You see, this sort of issues may rise. They may occur because you have multiple threads which are operating on this object now. We got multiple threads which are operating on that object. Yeah, yes. Yes, there is one answer. Well, first thread satisfied the condition and entered into sleep mode. Second thread entered completed with the withdrawal. Okay, yeah. So we're almost there, but the second point I'll tell you. You see, for suppose let's say the account balance is only 1,000. Okay, the account balance is 1,000. Now we have both the threads which are ready for withdrawing the amount. Let's say first of all the thread one, that account transaction one, the thread whose name is account transaction one, will check for the balance. It finds that there is sufficient balance. The balance is 1,000, so it is enough for withdrawal. So after it checks for the balance, so it will print this message that it is going to withdraw, and it will go into the sleep mode, right? So that first thread will go into the sleep mode. Now the second thread also will check for this balance. It will find that you see the first thread is yet to withdraw the amount. It is not yet done with it. Still, the balance is 1,000. The second thread will check for this balance. It also finds that there is sufficient balance, and it also prints that it is going to withdraw the amount. Meanwhile, the first thread, it might have come across of it might have come out of that sleep mode The first thread might have come out of the sleep mode, and it has withdrawn that amount. It has deducted that amount. Now the balance is zero, right? But the second thread, you see, which is also gone into sleep mode, comes out of the sleep mode, and unknowingly it will withdraw the amount. The balance is zero, so it will withdraw it. It will withdraw 1,000. So by making it, so what happens? So the account will be overdrawn, right? Yes. So this way, that issue might have occurred here in this place. Yes, not might. This is the reason I can say definitely. This is the reason why the account was overdrawn now. The account was overdrawn. Okay? Yes. Both the threads are operating on the same thread. Sorry, both the threads are operating on the same object. So this kind of issues are common. Yes. So hope you people got it. Now the question is, how can we avoid this issue? You see now the threads are overlapping, I can say. Now the threads have overlap. Now how can we address this issue? What do you people think? How to address this issue? Sorry. Yes. How can we address this issue? I'm sorry. Okay, so don't worry about the solution. At first place, yes, all of you, please confirm whether you understood this issue or not. Is the issue clear for you people, all of you? Can I have yes or no? Is this issue clear for you people? Okay. Oh, I'm sorry. I got one answer also, I guess. Sorry. Let me see from Saurav. By putting this piece of code in a block so that no, but piece of block so that no more than one thread can access it. Okay, fine. I do agree with that. Yes, we can do that. So, but how do we do that? Now let's see. So that is where we use this keyword synchronized. The solution is very simple here. All you need to do is declare this method as synchronized. Okay. So what if it is declared as synchronized? You know, at any given point of time, you'll find that only one thread will be able to execute this withdraw method. At any given point of time, only one thread will be able to execute this withdraw method. Yes. Okay. So what if only one thread executes this withdraw method? How we can address this issue? You see, through this withdraw method itself, you'll find that the threads are operating on that object, on that account object, right? Through the withdraw method itself, the threads are actually operating on the account object. Yes. So if you can make sure that at any given point of time only one thread operates, then we can address this issue. Yes, that is what we are trying to do. Okay, there is a lot to understand here with regard to the synchronized methods. We'll see that. But now let me run this code. Now we should not see overdrawing of that account. You see, this time definitely the account is not overdrawn. Yes, here the account, it is not overdrawn. Yes. Okay. Yes. How it works, how the solution works actually, that you need to know. So let me explain it. Here, for every object, you'll have a lock. Object lock will be there, or it is also called as a monitor. Yes, object lock or a monitor. You know, whenever the thread wants to execute a synchronized method, if it is supposed to execute a synchronized method, first of all, the thread is supposed to obtain the object lock. Okay, now it has to obtain which object lock, which class object lock. Now this method, it belongs to which object? That object lock it has to obtain. So now this method, it belongs to which object here? The synchronized method which you got here, this method, it belongs to which object? Yes, it belongs to a savings account object, right? It belongs to savings account object here. So that means it needs savings account object lock here. It needs savings account object lock. Yes. Okay. So for an object, there will be only one lock. Now, if that thread is able to obtain that lock, if the thread is able to obtain the lock, then it will be able to execute this withdraw method. Okay, then it will be able to execute this withdraw method. So now, for suppose in our example, we got two threads, right? Now let's say thread one, or the transaction account transaction one, that thread, let's say it has obtained that object lock and it has started with the execution of this withdraw method. Okay, now in that case, you see, meanwhile the second thread which you got here, account transaction 2, it also wants to execute this withdraw method. It also wants to execute this withdraw method. Okay, yes. So in that case, here this second thread also should obtain that object lock, right? But you see that object lock is with the first thread. The object lock is actually with the first thread here, right? So which is executing. The object lock is with the first thread, which is already executing. So that means, what about the second thread now? So the second thread here, it has to wait till the first thread finishes execution and releases that object lock. Okay, so the second thread, it has to wait till the first thread releases the object lock, and then you see it can execute. Okay, just a minute, please. Just a minute. Just a minute. Sorry. So hope now you people understood. So a thread, now if it wants to execute the synchronized method, so it got a condition here, right? So what is the condition? If the thread wants to execute the synchronized method, then what is the condition here? Yes. What it is supposed to do if it wants to execute the synchronized method? It is supposed to obtain, yes, what it needs, the thread, in order to execute the synchronized method, what it needs. It needs a lock. Yes. So basically it needs a object lock here. Yes. Okay, so a thread, if it wants to execute the synchronized method, synchronized non-static method, then of course it needs a object lock, I can say. Okay, it needs an object lock. Yes. Fine. So is this clear for you people? Anyone got any questions in this regard? Please let me know. Okay, good. Now I have few questions for you people. So first, suppose let's say we have this deposit method, right? Now let's say the deposit method is not synchronized. Just assume that the deposit method is not synchronized. Yes. Now you see, let's say one of the threads, let's say thread 1 is executing the withdraw method which is synchronized. That means it has to obtain that object lock, then only it can execute that withdraw method, you know that, right? Yes. Fine. So you know what, here the second thread, let's say, which you got here, it wants to execute the deposit method. Let's say first thread is executing the withdraw method, so it has obtained the object lock. Okay, and the second thread, now it has to execute this deposit method. Now the second thread, will it be able to execute this deposit method? Yes. The second thread, will it be able to execute the deposit method? Meanwhile, you see, when the first thread is executing that withdraw method, what do people think? Yes. Yes, that's true. So yes, of course it is possible, because you know the first thread, it is executing a synchronized method, so which needs an object lock. But the second thread, you see, it has to execute this deposit method which is not synchronized. And if that method is not synchronized, if the method is not synchronized, then in that case the thread need not obtain an object lock. Okay, it need not obtain an object lock. So thread, it doesn't need any object lock here for that purpose. Okay. Yes. So first suppose, what if, hope you people got this point, right? Now first suppose, let's say, now you have two threads which are operating on the same object. Okay, both the threads are operating on the same object. So the first thread is executing the withdraw method. Okay, so the second thread here, so will it be able to execute the deposit method? The second thread here, will it be able to execute the deposit method? Okay, Saurav says yes. So what about others? What do you people think? Actually, I can say no, because as I told you people, both the threads are operating on the same object, right? Now the first thread has obtained that object lock because it is executing the withdraw method, which is synchronized. Now you see the second thread also wants to execute this method. Okay, the second thread wants to execute a different method. Okay, deposit method, but it is also synchronized. Okay, yes, and both the threads are operating on the same object. That means for that object there is only one lock. That object lock is already with first thread. The object lock is already with first thread. Okay, yes. So here you see the second thread will not be able to obtain that object lock because it is with the first thread. So second thread will not be able to execute it. Yes. Yes, very much, because that object lock is important, right? The threads have to obtain the object lock in order to execute. The object lock should be available for the threads in order to execute that synchronized methods. You people got it, all of you? Yeah. Now I have another question. All of you, this is important. Now these are different scenarios or different cases, I can say. Now we saw two possibilities. Now the third possibility. For suppose, let's say the first thread is operating on the first account. Now you see you have two threads, right? Each thread is operating on an account object. Let's say each thread is operating on a different account object. So that means both the threads are not operating on the same account object. Both the threads, they're not operating on the same account object here. Yes. Both the threads are not operating on the same account object. Yes. So thread 1 is operating on a one account object, and thread 2 is operating on another account object. So in this case, let's say the first thread is executing the withdraw method. That means it has obtained the object lock and is executing the withdraw method. Now you see the second thread here, it wants to execute the same withdraw method. Let's say the second thread also wants to execute that withdraw method. Okay, now in this case, what do you people think? These two, the second thread, will it be able to execute that withdraw method when the first thread is executing the withdraw method? Yes. The second thread here, will it be able to execute the withdraw method when the first thread is executing the withdraw method? Yes. What do people think? Yes. Okay. Yeah. That's a right answer. Yes. Because you see, these two threads, as I told you people, they're operating on two different objects, two different account objects. So if first thread is executing the withdraw method, that means the first thread has obtained the account object lock, okay, on which it is trying to operate. Now second thread is operating on a completely different account object. Now if it wants to execute, then it means it has to obtain that object lock of that account object on which it is operating. And if it is able to obtain it, definitely it will be able to operate on that withdraw method. So these two methods are, these two threads are not operating on the same account object. These two threads, they are not operating on the same account object, right? They are operating on different account objects. So they can obtain that object lock independently and they can work. So there won't be any issues in this regard here. Okay. Yes. So hope you people got it. Yes. Okay. Yes. Okay. Yeah. So now you see, we have declared this deposit and withdraw methods as synchronized. So these are the two methods through which the threads will be operating on this object, I can say. And they both are synchronized now. Okay. Yeah. Okay. They both are synchronized. And through this methods itself, the thread will be able to operate on this objects. The threads will be able to operate on this object, right? Yeah. Now we have made sure that I can say that we have made sure that at any given point of time, only one thread will be operating on this object. I can say that by declaring this method sir, okay, as synchronized, we are making sure that at any given point of time, only one thread will be operating on this object. Okay, so that means now this type of objects, we call them as thread safe objects. Thread safe object, we call it as a thread safe object, means the object on which only one thread will be able to operate at any given point of time. At any given point of time, only one thread will be able to operate on this object. So this is about a thread safe object. Yeah. Okay, there is a question, let's see, from Saru. So what would be the state of a thread when it is waiting to get the lock? So the state of the thread will be when it is waiting for the lock. So the state of the thread will be running itself. Yes. You know, uh, uh, you'll find that the thread, okay, if it is, okay, sorry, if it is already, no, just a minute. So you said, what is the thread, state of the thread when it is waiting to get a lock? Yes. Now let's say the thread is in execution. That means it is in running state. Now it has to obtain the object lock, right? So I can say that it will be in blocked state. Okay, I can say that the thread will be in this blocked state. So it will, that is almost similar to a sleep state. So it will be waiting for that lock. Okay, it will be waiting for that lock. So once the lock is obtained, it will resume execution. Okay, yes. So when the thread is in blocked state, I can say that the thread will not be executing any instructions. It is just sitting idle and waiting for that lock here. Yes. fine. So next, you know, this methods which we saw now, the methods which we saw now, actually, if you have noticed these methods, you will find that these methods are non-static methods, non-static synchronized methods, I can say. These methods are actually non-static synchronized methods. Okay, yes. You know, here, when the thread is supposed to execute a non-static synchronized method, so it has to obtain an object lock. Okay, yes, it has to obtain the object lock. What if you got a static synchronized method? Let's say you got a method which is static and it is synchronized. For suppose you have the static method, right? So we can also declare the static methods as synchronized. We can also declare the static methods as synchronized. Yes. So what if the thread wants to execute a static synchronized method? Then what will be the what will be the requirement here? So if the thread wants to execute static synchronized method, then what it is supposed to do? Yes. You know, is anyone familiar? If the thread wants to execute a static synchronized method, then what it is supposed to do? In that case, the thread has to obtain a class lock. We'll have class lock. The way we got the object locks, so whenever the thread wants to execute a non-static synchronized method, whenever the thread wants to execute a non-static synchronized method, in that case, you see, the thread is supposed to obtain an object lock. Here, if the thread wants to execute a static synchronized method, if the thread wants to execute a static synchronized method, then in that case, it is supposed to obtain a class lock. Okay, in that case, it is supposed to obtain a class lock here. So hope you people got it. Yes. So for a class, there will be only one lock. For a class, there will be only one lock. Okay, and the thread should make sure that it obtains the class lock here. Okay, yes. So when the thread has to obtain a class lock, when it wants to execute the static synchronized method. Yes. You know what? You'll find that here we got static, sorry, we got one issue with the synchronized methods. Though they are static or non-static synchronized methods, there is one issue, one drawback I can say, one limitation is there. Can you people tell me what is the limitation here? Yes. What is the limitation? Yeah, you see, you'll find that the threads, you see, if they have to execute the synchronized method, so it would take more time for the execution. It would take more time for the execution, of course. That's right. Because you see, so if one thread is executing, then the other threads which want to execute the same synchronized method, they have to wait for this thread to finish execution, right? They have to wait for this thread to finish execution. Yes. So until and unless this thread finishes execution, so the other threads will not be able to execute. Yes. The other threads will not be able to execute here. Yes. So that is a limitation. So it will slow down the execution here, right? Yes. So what is the solution for this issue? How can we fix this issue? Can someone answer this question? How can we fix this issue here? Uh, just a minute, please. Just a minute. Yeah, I'm sorry. Yes. So, any answer for this question? So, how can we fix this issue? You know, that is where synchronized blocks are used. Synchronized blocks are used. Okay, that is where we use synchronized blocks. Yes. So you see, generally what happens is if you declare a method as synchronized, so any thread which is executing this method has to make sure that it holds that object lock till that thread finishes execution of this withdraw method. Okay, so the thread has to hold the object lock till it is done with the execution of this withdraw method. Yes. Okay. So if that method is lengthy, if you got a lot of instructions, and of course the amount of time you see for the thread to execute that method also will be more. Until that time, it also has to obtain the object lock. See, that's the reason why instead of declaring the method as static, declaring the method as synchronized. Yes, try to only declare part of that method as synchronized, where you're modifying that object state. Wherever you see you're dealing with that modification of that object state and all, so that part of the code only try to add it to a synchronized block. So you can declare a synchronized block. You can that means part of that method you can declare it as synchronized. Okay. Yes. And that part of that method here, it is called as critical section. Yes, you can call it as a critical section. That means where the actual updation of that object takes place. So that is one solution. So that means instead of synchronizing the whole method, we can only synchronize part of the method. So that you see, only for that part of that method, when that part of that method executes, so the thread has to obtain that object lock. That's it. Yes. Now I want you people to check the synchronized blocks on your own. So I won't show you people here. So I will leave it to you people. So there is nothing much special about it. The only thing is instead of declaring the whole method as synchronized, so through the synchronized blocks, we can declare part of that method as synchronized. I can say part of the method we can declare it as synchronized. Yes, that is the difference. Okay, so this is about synchronization. Now you understood this thread safe objects also, you see, and synchronized keyword. So what happens if a method is declared as synchronized? Yes. Yeah. So if it is clear, now let's move on. Yes. Okay. You see, it will be blocked till it is given that lock. Yes, it will block it till it is given that lock. Yes, it will be never ending. That period will be never ending. So there is no limit for that. Unlike your sleep, where we instruct the thread to wait for a particular period of time. So here we don't have, uh, there is no time limit. It's not time bound. Yes, it internally does that. Okay. Yes. So it will regularly check for that lock. Of course, it does that. Yes. But there are no methods for us to control this. Yes. Now the threads have to take care of this. You see, now so far we have never, we are talking about logs, but we have never written any code to obtain that object logs to release the object log. That part we're not dealing with it. So if you have noticed it, so uh, the threads itself, they will take care of it now. So we are not involved here in that. Okay, all of you. One thing which you need to notice here is that, so we don't need to again write any additional code to obtain this object logs and work with this object logs and release them. So that will be taken care by the threads itself. Yes. Okay. So now there is one more topic. Maybe I need 1 hour or so for this. So without a break, shall we continue? The next topic is regarding the thread communication. Yes. So will you be able to bear with me, or else shall we take a break? So I need 1 more hour. So without a break, you can just continue if you want. Yeah. Okay. I guess we'll go for a break then for 5-10 minutes. I'll say 5 minutes. Of course, it becomes 10. So after the break, we'll continue discussion. Okay. Yeah. Just take a 10 minutes break, but come back quickly. We'll continue discussion. Okay, so hope everyone is back. Yes. Shall we start, all of you? So can you people hear me? Are you people back? Yeah. Hello. Okay, fine. So hope everyone is back, right? Yeah. Okay. So let's start. Now, the another important topic here is how threads can interact with each other, how they can communicate with each other. So that is what we'll try to do now. Okay. Yes. To make you people understand this concept, this is very important. So I will consider an example. Producer and consumers. Producer and consumer. So basically, this is an example where you will have two different types of threads. You'll find that we'll have a thread called as producer, which will be responsible for producing the data. Okay, producer thread, it will be responsible for producing the data, I can say. And you see, the consumer thread is responsible for consuming all the data which is produced by the producer. So it is the responsibility of the consumer to consume all the data which is produced by the producer. You'll find that here these two threads will be continuously executing. These two threads will continuously execute here. So they will never stop. They will continuously execute. Yes. So let's check this example once and let's see what is the problem here. I'll show it pictorially. Now, here these two threads, let's say they're operating on object, some object, let's say X object here. Okay, we got a producer thread, and we got a consumer thread. So both the threads, they will be having access to the same object. So producer thread, as I told you people, so it will produce the data, right? So whatever the data which it produces, what it does, it will add it to that X object. It will add it to that X object. In the consumer thread, you see, it will read it from the X object itself. It will read it from that X object. Let's say you have the data here in this object. So you got some variable which holds that data. Yes. So this is the example which we need to implement now. So let's try to implement this example. Okay. Yes. So first of all, you see, we need to define a class here. Let's say I'll call it as X, which holds the data. I'll call this class as X. We have a variable here. I'll add this methods. Get method, and the put method. You see, this is a very simple class called as X. The class name is X. In this class X, we got this variable data. Yes. And you see, it's an integer type. To read the data from that variable, to assign the data to that variable, we got methods here. Yes. You see, get method and put method. Okay. Yes. So this class object will hold the data. The X class object will hold the data. Now we have to define a class. We'll say we'll call it as producer, and I'll make it implements runnable interface. And you see, in this class we'll define the task for the producer. So what exactly the producer thread is supposed to do? So the task for the producer thread will define in this producer class run method. And you see, similarly, let's define another class from the consumer as well. Let's define another class for the consumer. Yes. First, let me define the class and then we'll write the code. Okay. We'll also make this class implements runnable interface. We'll override that run method, please. Okay. So now the producer thread is supposed to produce the data and it is supposed to add the data to the X object. That means, so the producer thread here, it needs the reference to the X object, right? It needs the reference to the X object. So I'll declare a variable here of type X. And we'll add a parameterized constructor so that through this parameterized constructor, the X object reference can be passed on to this producer. Okay. Yes. So now let's implement that run method here. You see, I'll declare a temporary variable X dot put of plus plus I. So this thread is calling that put method and it is passing an integer value by incrementing it. So each time it passes an integer value to that put method here. Yes. Okay. Yes. Okay. So this is what the producer will be doing. Produces the data and it will add it to that X object through the put method. Okay. Yes. And whenever this put method executes, I'll print this message put and that value, the data which is added. Okay. Now similarly, now you see Even the consumer needs a reference to the text object because it has to read the data which is in the text object. So we'll add a parameterized constructor. So this is a parameterized constructor. So this thread is supposed to read the value. So how it will read the value? Through the get method. It will call the get method. Now whenever the get method is called, see, we'll print that value here. Okay. Yes. So the consumer thread will use that get method to read the data, whereas the producer thread will use the put method to store the data into the data variable of the X class object, I can say. Yes. So now we have this task defined. Let's try to start this threads. Okay. So we'll execute this threads. First of all, I'll create the text object. Let's create a producer thread. Now, actually, I'm sorry. Here, I have to concentrate on one thing. I'm sorry. I want this threads to continuously execute. So if that is the case, then make sure that use a for loop here, right? Yes. Or you can use a while loop. Anything is like while true. Okay. So that means the producer thread will continuously call the put method. So it will repeatedly execute. The same should be the case for that consumer as well. So that get method should be called repeatedly. That means the consumer thread will be repeatedly reading that data. Okay. Yes. Fine. Now let's create the producer. I'm creating the producer object, right? And we'll create the consumer object. We will create a thread. Say the reference variable name. We'll call it as producer thread. Pass a runnable object reference. We'll create another thread, consumer thread. We'll pass a consumer object reference. So now let's name this threads and we'll start executing that. Yes, let's name this threads. Producer thread dot set name. Let's say it is producer, and the other thread is consumer thread dot set name to consumer. Let's start this threads. That's it. Okay. So let's run this code. So what happens? Let's see. So now producer thread, what it is supposed to do, it executes that. It will call the put method repeatedly. It produces that data, that integer values, and it will pass them to the put method. So that put method will store that data into that X object, I can say. It will store the data into the X object. Yes. Fine. The consumer thread will be calling the get method. Through that get method, it will read the data which is in the X object. Yes. Okay. So let's run this code. Let's see the output. Okay. Now I want you people to just check this output here. I stopped this loop in the middle of the execution itself. You see? Now just check this output and tell me whether there is an issue. Yes. Okay. Yes, you see, the producer thread, no, actually the producer thread and the consumer thread here, I can say that they are not coordinating properly here. They are not coordinating with each other properly. Yes. Both the threads, they are not coordinating with each other properly. You see, the producer thread, after it produces a value, so the consumer should be able to consume that value, right? You see, after the producer thread produces the data again, the producer thread is producing the next value. That means the producer thread is not giving the chance for the consumer to consume the data. Yes. So before the consumer consumes the data, the producer again produces fresh data. So it is not giving the chance for the consumer to consume the data here. Okay. So now you see the same is the case with the consumer also. Consumer is also, it's not any better. The consumer thread here, which executes that get method, you see. So it reads that value. So after reading the value, now again it reads the same value continuously here, you see, 109 double and 109,399. It reads that value continuously. So what it implies? Here it indicates that the consumer thread, after it is done consuming the data, again it is not giving the chance for the producer to produce fresh data. So it reads the same data again, consumer thread. You'll find that it reads the same data again. Yes. So the threads, they're not coordinating with each other properly. Okay, which results in this issue. So what is the issue? So the producer is producing the data, but the consumer is not able to consume all the data which is produced by the producer. Yes. Now the issue is with both the threads here. So how do we fix this issue? So what do you people think? So how to fix this issue? So can you people give me some solutions for this? You see, so the main thing is here, the threads, they have to coordinate with each other. They have to properly coordinate with each other. Yes. You see, the producer thread, after it is done producing the data, so it should actually give a chance for the consumer to consume the data here. It should give the chance for the consumer to consume the data, right? And the consumer also, after it is done consuming the data, it should give the chance for the producer to produce fresh data again, right? So see, when one thread is executing, the other thread should sit idle, so it should not execute. Okay, so it should wait for the other thread, I can say. So now the question is, okay, after the producer, let's say it produces the data, so it will wait for the consumer. Now how long the producer should wait for the consumer, and how the producer will know that how the producer will know that the consumer has consumed the data. There should be some sort of means here, some source to understand whether the consumer has consumed the data or not. Yes. Right? Yeah. So how long the producer is supposed to wait for the consumer thread? You see? Yes. The producer thread, once the consumer thread, once it is done consuming the data, so it can notify or it can inform to that producer that it is done with consuming the data here. Yes. So that the producer thread again will produce the data. Meanwhile, what the consumer is supposed to do, so it is supposed to sit idle. Again, that consumer, how long it is supposed to sit idle, in depends on that producer. So once the producer is done producing the data, it should again inform or it should notify to the consumer that it is done producing the data, so that the consumer can consume that data here. Yes. Okay. Yes. So this is a strategy which you need to follow here. So this is the strategy. Yes. So now let's try to implement this strategy here. So first of all, I will use a variable which acts as a flag here. So that there should be some sort of source. There should be some source for the threads to understand which thread is currently executing. There should be some sort of option for the threads to understand which thread is currently executing, so that the other threads will sit idle. So the other thread will sit idle, right? Yes. So here the threads, they use a flag for this. So I will add a flag. We need to implement that thread behavior, right? So let's add a flag. Boolean flag. Let's say we'll set this flag value to false. Okay. So for suppose, let's say if this flag value is false, if flag is false, Let's say it is producer's turn, and for suppose if flag is equal to true, let's say it is consumer's turn. Okay. So now I will write that logic here. So which thread will execute this get method? Which thread will execute this get method? Yes, the consumer thread will execute this get method, right? So first, when this thread starts execution, we'll check this flag value. So consumer has to check that flag. So if flag is what? If it is true, then it is the consumer's turn, right? So what if it is false? What if the flag value is false? Then what this consumer has to do? If the flag value is false, then it is not the consumer's turn, right? If the flag value is false, then it is not the consumer's turn here, right? Yes. So it is producer's turn. So what exactly the consumer is supposed to do during this time? What exactly the consumer is supposed to do here? See, flag value is false, then the consumer is supposed to wait, right? Yes, I will add this wait. And also please make sure that you declare these methods as synchronized. Okay. Also please make sure that you declare these methods as synchronized. Yes. Now you see, so that we'll make sure that only one thread executes. Okay. Now what I'm doing, so if this flag value is false, that means it is not the consumer's turn to execute, so it is producer's turn. So if it is not consumer's turn, then what the consumer is supposed to do here? So the consumer is supposed to wait for the producer to execute and to produce the data. So how can we instruct this consumer to wait for that object? So it is supposed to wait for what? So it is supposed to wait for what? For that object. We see this dot wait, we are calling this dot wait. This means here it refers to which object here? This refers to which object? Can you people tell me? This refers to which object? Uh, no. Where is this method defined? Get method. Where is this get method defined? In the X class. Okay. it actually belongs to that X. That this here, it refers to X object. X. Get method belongs to which class? X class, right? So that current object reference, that get method, how it is called? Using that X object reference itself. It's a non-static method. Get method is a non-static method, right? So that current object reference will be used to call this get method. So that object reference will be stored in this variable. That means, you see, so when you call the wait method this way, when we call the wait method here this way, you see, by using that object reference, which object reference? X class object reference. So this indicates that we want the thread to wait for that X object. It indicates that we want the thread to wait for that X object here. Okay, we want the thread to wait for X object. Yes, fine. So what if the flag value is not false? Then what? If it is not false, that means if it is true, that means it is consumer's turn. So if it is consumer's turn, it should read the data. You see, that is what it is trying to do here. It will read the data. And after reading the data, now what the consumer thread has to do here. So this is important. After reading the data, what the consumer is supposed to do. First of all, it has to change that flag value. Set the flag value to true. Sorry, it is already true, right? So it has to be set to false. And what this consumer has to do, for suppose if there is any producer waiting, if the producer is waiting for this object, so it should notify that object, that thread, producer thread. It should notify that producer thread, right? Yes. It should notify that producer thread. Yes. So how it will notify the producer thread? It uses this again, this dot notify. That means if there is any thread, so which is waiting for this X object, so this, it holds a reference to that X object, right? Yes. So if there is any thread which is waiting for that X object, so that thread will be notified here, I can say. That thread will be notified. Yes, that is what happens. So after that thread is notified, you know, what happens to this consumer thread? Will it stop execution? After notifying the consumer thread, will it stop execution? I can say it won't. It won't immediately stop execution. So it executes that infinite loop, right? So again, it will try to execute this get method, which set the consumer itself. But this time the flag value is false. So because the flag value is false, so what it does here, you see, this code executes, which instructs this thread to wait. Now what happens when the thread is instructed to wait? So it will move from the running state to the wait state. And you know, there is one more important point here. When the thread moves from the running state to the wait state, so if it holds any object lock, it will release it. If it holds any object lock, it is going to release it. Okay. If the thread, if it holds any object lock, it will release that object lock, and then it will go into the wait mode. Then it will go into the wait mode here, I can say. Okay. Yes. A wait state. So this is how it works. Yes. Now you see, the other thread also, you're supposed to implement it similarly. So what to do? So if flag is false or if flag is true, if flag, that means if it is true, then whose turn it is? It is consumer's turn. If flag value is true, it is consumer's turn. So yeah, tell me. I guess okay, ask me, let me see. So if I complete this discussion, maybe you'll have a better understanding of it. So let me complete it otherwise, okay? So that you'll have better understanding of it, then you can ask me question. So now this flag value, if it is true, that means here, if the flag value is true, that means it is actually the consumer's turn. So if it is consumer's turn, then what this producer has to do, it has to wait, right? Again, we need to write this code. So this dot wait, that means we'll instruct this producer to wait. So for this X object here, we're using X object reference, right? So that means it will wait for that X object, I can say. It will wait for that X object, yes. So once you see, we instruct that thread to wait, what it does, as I told you people, it will relinquish the object lock, it will release the object lock, and it will go into the wait state. After it releases the object lock, it will go into the wait state here. Yes, fine. So what if this flag value is not true? Let's say if it is false, then this block will not execute. This if condition will not execute. So the thread will read that data. After reading the data, you see what it has to do. Sorry, it will add the data, I'm sorry, to the text object's variable data. After adding it, it has to change the flag value. Now what should be the flag value? Why it has to change the flag value? So that it gives a chance for the other thread to execute. It has to change the flag value so that it gives the other thread the chance to execute. So what should be the flag value now? Yes. So what should be the flag value? Now this thread is done with the execution, right? So when it will be able to produce the data when that flag value is false. Now this value has to be set to true now. It has to be set to true now. Okay, so that it gives the other thread the chance to execute. If flag value is true, that means it is consumer's turn. You see, line number 7. If flag value is true, then it is consumer's turn. Yes. Okay. So after setting that flag value to true, so it is giving the other thread the chance to execute. So it will notify that other thread. Okay, it will notify the other thread. After notifying, you see this is the thread will execute continuously, right? Now what happens after notifying? Again, this this thread, producer thread, will execute the put method. You see, this time the control enters into this put method, but the flag value is set to true. So because the flag value is set to true, so what happens? You see, the thread will go into the wait state here. Okay. So we're instructing the thread to wait for that X object, I can say. We're instructing the thread to wait for the X object. Yes. Okay. Yes. So once the thread goes into the wait state, you see, now the other thread gets a chance to execute here. So you see, whenever the thread goes into the wait state, you know what? If there is any object lock, so it will relinquish it. That is important to understand. Okay. Yes. Only after relinquishing the object lock, the thread will go into the wait state here. Yes. Okay. So let's try to execute this code once. Let's see whether we are able to fix this issue or not. Now you check the output and tell me, did we fix the issue? Sorry. Yes. Okay. Now see the threads, their execution, they are executing appropriately. They're coordinating with each other, right? Yes. You can say that the threads are interacting with each other, coordinating with each other properly. Yes. Okay. Now you people tell me if you people got any questions. Yes. Okay. Yeah. Not only deadlock, that is how the other thread will be able to execute. If this thread, if it doesn't release the object lock, then how come the other thread can execute? It won't be able to execute if this thread holds that object lock. Okay. Yes. So any other questions? Now let me see how far you understood. So my question is how those threads are able to communicate with each other now? How they are coordinating with each other? What is making these two threads to communicate with each other? Through the common object, and we got this methods, right? Notify method especially, and wait method. So through that, yes, common object. Now you see the thread is, we are instructing the thread to wait for that object, and the other thread can inform all the threads which are waiting for that particular object using the notify method. Okay, yes. So where are these methods defined? Wait and notify methods. In which class they are defined? Okay, thread class. Yes, that's right. Not in the thread class. You will find that these methods are actually defined in the object class. Okay, they belong to the object class here. So we are not calling that methods using the thread class object reference, right? So using which class object reference here? The text class object reference, which is a normal class. So it inherits that notify and wait methods from the object class itself. So this is one important point which you need to remember. So notify and wait methods, they are actually defined in the object class. Okay. So now we have notify all method. Notify method, you'll find that it is used to notify the thread which is waiting for a particular object, right? Notify method is used to notify a thread which is waiting for an object. Yes. Now here, for suppose if you have more than one thread which is waiting for a particular object, if you want to notify more than one thread which is waiting for a particular object, in that case use notify all. In that case use notify all. Okay. Use notify all method. Yes. Okay. Next important thing, you see generally you can call this notify and wait methods within that synchronized methods itself. You'll find that always you can call this methods in the synchronized methods itself. Yes. That means the thread on the thread, if you want to call this methods, you have to make sure that you have that object lock. Yes. Okay. So this is about the thread communication. So next, the few small things which you need to know. For the threads, we have a priority. For the threads, we'll have a priority. So I want to show you people that priority ones. You know, By default, the priority of the main thread is 5. Priority of the main thread is 5. That is called as normal priority. And you know what are all the threads which you create in the context of main thread? They are called as child threads, and you will find that even the child thread's priority also will be same as the main thread priority. It will be same as the main thread priority. Now, under the context of main thread, now we are creating two threads, right? So what are those two threads? Producer thread and consumer thread. Producer thread and consumer thread. Yes. So the priority of the producer thread and consumer thread will be same as the main thread priority. You know, I can say that this producer thread and the consumer thread, they are child threads of main thread. They're actually child threads of main thread. Yes. They are child threads of main thread. So, and the priority of those threads is always normal priority, which is same as that main thread priority. Now, if you want, you can read that priority as well. You see, let's read the maximum priority. That constant variables are there which hold this priority values. Thread dot max priority. Similarly, min priority and the norm priority here. Yes. Okay. And let's read the priority of this thread also. Priority of consumer thread, let's say. Consumer thread priority. Consumer thread dot get priority method is there. Okay. Yes. Okay. Yes. So let's run this code. You see. So consumer thread priority is 5, which is a normal priority we say, and it is the default priority of your main thread also. Now, the maximum priority which you can have for the thread is 10. That is the highest priority which you can have for the threads. And the least priority, minimum priority can be 1. You see the normal priority is 5. Now, what is the purpose of the priorities here? What do you people think? Why do we need a priority for the threads? Yes. Yeah, you see, based on the priority, the preference can be given to the threads. That means to which thread the processor should be assigned first. That sort of preference, you know, it will be possible to set that priority here. Okay. So the priority will help us to give the preference. Okay. Yes. So you see, if more than one thread have arrived at the same time for the processor, now which thread should be given the preference? So it depends on the priority. So the more the priority, the higher the preference will be given here. Okay. So that means if you consider two threads, let's say one of the threads priority is 5, the other one thread's priority is 10. So the thread whose priority is 10 will be given more preference here, I can say. The thread with the priority 10 will be given more preference. Yes. Okay. So now there is one last thing, but I will leave it to you people intentionally. So I want you to check this. So please try to explore it on your own. So if you got any issues, let me know. Okay. What is it? The join method. So I will leave this join method to you people. So just check this method called as join. So I'm leaving it to you people. Okay. Yes. Join method. Okay. Yes. So with this, I'll close this threads also. Okay, we are done with this threads concept. Yes. So let's stop it here. Now we'll meet tomorrow at our regular time. Yes. So you got two batches, right? So we'll meet at our regular time. So what is it? What if we have more than 10 threads? How, it doesn't matter how many threads you got. It's always the priority of the thread will be in the range of 1 to 10. That's it. Doesn't mean that, if the highest priority is 10, it doesn't mean that we can only set the priority for 10 threads. Okay. Yes. So you may have 100 threads also. For all the 100 threads, the priority will be set between 1 to 10. That is the standard range. At any point of time, at any given point of time, the priority of the thread will be between 1 to 10. Okay. Yes, that's right. Yeah. Okay. So So volatile variable means, okay, there is a variable called as, so we got a keyword called as variable, volatile, which you people can use. Yes. Here, yes. This variable, if you declare it as volatile, that means, so we'll not consider this variable for synchronization, I can say. Okay, yes. This variable will not be considered for synchronization, and you should not use this variable for any operations pertaining to the synchronization. That is what a volatile variable, I can say. Okay, yes, that is what a volatile variable is. Yes. So the variable which should not be considered for synchronization, which should not be used for the synchronized methods of blocks, I can say. Yes. That means this variable value is highly changeable. It may vary highly. That value may vary, which should not be considered. The meaning itself indicates volatile means which is very subtle, which varies drastically, dynamically. Yes, that is what volatile means. Yes. So generally we don't consider it for synchronization and all. Yeah, that is what volatile means. Yes. So any other questions? Yes. Okay, sure. Okay, you're welcome. Thank you. Yes. So that's all for today then. Okay. So let's meet at our regular time tomorrow. So we got people at 8 p.m. Central Time, right? For you people, the class is 8 p.m. Central Time. And for the people who are attending the class at 8 a.m. Central Time, we'll have the class tomorrow at 8 a.m. So there is no other class today. Okay. So there is no other class today. That's it. Yes. And Lal, let me see. I may have that JPA records, so I'll try to share it. Okay. Yes. Just by tomorrow morning, I'll try to do that. Okay. Yes. So tomorrow, not now. Tonight it won't be possible. Tomorrow I'll do it. Yes. Okay. So the next topics will be advanced topics. We'll start with JDBC programming for 8 p.m. batch. Okay. Yes. Fine.